example that you have on the paper, K-4, what's the name of it? Permanganate. Okay, potassium permanganate. Example 2. Example 2. Ammonium phosphate. Example 3. Hydrochloric acid. Good. You're recognizing your acids. Example 4. Aluminum sulfate. Good. Next. Ooh, there's a typo on that one. Oh, listen to this one. MgNO3 parentheses 2. Put a 2 there. No one caught my typo. Sly as a fox. Okay, no. I try to make sure superscripts and subscripts is a type. Occasionally a butterfinger slips up. Okay, so that is magnesium nitrate. Okay, so I can ask you to find the percent composition of any compound, but I would probably give you the name as a word form, and you'd have to write the formula out to actually get the formula, to get the individual elements. So let's talk about the second one, NH4. 3PO4, and you guys have this on your paper, so I'm just probably do one of these because it's very redundant, and then we're going to talk about hydrates, which is our next kind of main topic. So percent composition is much easier than just mole conversions. Mole conversions I wanted to give you guys early so you guys have some time to let that kind of simmer. So if I'm looking at this compound, how many nitrogens are there? There are 3, because what are you doing? Distributing the 3 in, right? So did I grab the thin one? Sorry. Okay, good. All right, so there are 3 nitrogens. There are how many hydrogens? 12. 3 times 4. Yeah, there are 12 hydrogens. There are how many phosphoruses? 1 phosphorus. And how many oxygens? 4. Okay, so when you add up these masses, that's your total molar mass, right? So what's your total molar mass? 3 times like 14 grams plus 12 times 1.008. This is hydrogen. Plus 1 times 30.97, is that phosphorus? Okay, plus 4 times 16 for oxygen. So you add up all of those together, it's your total molar mass, which is what? Anybody got that far? 149.12. Can I get a second on that? It's okay if we get different answers. I just need some seconds and thirds of this. 1.9. One more time? 1.9. Okay, 149-ish is good. Okay, cool. So 0.96 or something like that. All right, so this is the total molar mass, about 149. So if I wanted to find the percent of hydrogen, you're going to take all of the hydrogens, all of them together, there's 12 of them, over your total molar mass of ammonium, which is our only polyatomic that's positive, phosphate. And you're going to times that by 100, right? But instead of writing it like this, because it doesn't give me a lot of information, what are you guys writing instead? 12 times, what's the molar mass of hydrogen? 1.008 grams mass, right? Divided by total, which was 149 something and some change grams, and this is our total compound, and this is just of hydrogen, times 100, and what do you get for your mass percent of hydrogen? Something small. What's 12 divided by 149? 8%? Can you give me some extra? Can you give me some extra?
8.11.
Okay, I'm good with that. 8.12. Okay. So 8% hydrogen, and then for your secondary one, I just chose hydrogen first. How would you do differently for nitrogen? So this was our percent hydrogen. How would I do nitrogen? So 3 nitrogen, so that's 3 times, what's nitrogen's molar mass? 0.1. That over, again, the total molar mass. Okay, so this is going to be for nitrogen, times 100. What's your percent for nitrogen? Say again? 28. Can I get somebody else? Verify? Thank you. 28 point what? Say again, Mikhail? 19. Okay, I'm extending it to 2 decimal places so I don't have too much rounding error right now. All right, so then phosphorus, percent by phosphorus, is, how many phosphoride did I have? 1 times the 30.97 grams, which is straight off the periodic table, over 149.096, and times 100. What's our percent there? 20.77%. All right, what's my last element I've not gotten a percent comp for? oxygen, right? I could do the same process. I could do the percent by part over whole, so individual oxygen over the total molar mass. Or if I was a smart cookie, what do all percents of a specific total always equal? 100, right? So 100% is my total, because I can't have like less than 100% of my total compound. So if I have 100%, so I know is my final part, and I have 3% already, boom, boom, boom. What do these add up to be? 56. Say again. Say again. Yeah, no, that looks good. Oh yeah, 77 here. So 57.08. Thank you. All right, so if that so far is 57-ish, how much does oxygen make up? About 42%, because it's going to be making it the residual part of 100. So if you do 100 minus the percentages we already got of 57.08, the rest is going to be oxygen. So that was what, 42%? And that's going to be oxygen versus doing the whole thing again. So you've got two ways to approach it. Give me a thumbs up if you feel okay with percent comp. But you really have to know the formulas, right? That's probably the hardest part still. All right, so you guys still have your computers out. Do me a favor. Go to my website. I'm going to show you how we're going to work through this last part together. So this is about hydrates. So a hydrate we've already spoken of. We already kind of know that there are some compounds that are ionically bound. So like this slide structure here is an ionic slide. But inside of the little holes, because it actually can hold water molecules. The water molecules hydrate the compound, and we just call the compound a hydrate. So let's look at the second question, or this number 3 down here. This is the pre-lab activity. There's going to be a simulation where you do like an online dehydration lab. You just have to collect the data, and then you'll do your math from there. It's kind of a practice math heavy day. So if I look at this guy, BaOH2. What's just BaOH2? Name it. Barium hydroxide. And then separately, you see this dot. Dot does not mean multiply. Dot just means, hey, I'm here. And then 8 waters. How do you say 8 waters? Octahydrate. Barium hydroxide octahydrates. How do you name your hydrates? We've had 2 or 3 examples like that so far. Not too many yet, so I'm just kind of giving you some new information. So when it has the waters embedded in the formula like that, we call it a hydrate. But what you can do is you can heat up something like that crystal. This is actually what you did in your one of your labs in the first week. And we dehydrate, all the water comes out, and we call it an anhydrate. Because what's an mean? Not, okay? So that's going to help you define the words hydrate and then anhydrate or anhydrous. That'll help you there. Other than that, I think that you guys know how to do the pre-lab. Yeah. You guys have, let's say, 8 minutes or so to knock out the pre-lab questions. I have them here, but on my website, if you also want to pull them up to have them in front of you, it's under Unit 4. It says percent composition simulation pre-lab questions. When you click that, there should be, actually, that should be the pre-lab questions. Percent composition simulation is going to be here too. So I have that, the pre-lab already pulled up for you. The simulation looks like this. It gives you an intro to the hydrates. So go ahead and let you guys pull up some of the documents while I leave this on the board for you. So I'm going to say 8 minutes, complete your pre-lab. This needs to be on a separate sheet of paper because it's not a partner. I mean, you of course work within your groups, but I feel like you're not, maybe not finished. What's that, 30 minutes? Okay, maybe 25 minutes. You probably will get close to finish. But if you don't finish, you'll finish the problem. I'll show you guys more of the on our website. It's $100. I really want to make sure you're comfortable with pre-lab before you begin the simulation. So I'm going to do that right now. Oh. The pre-lab questions are on the board. They are also on my website. So So this one, number one specifically just says percentage of silver in silver sulfide. Not the sulfide part, just the silver part. Write out your work to I mean, a borrow calculator.